Higher maths, functions and graphs, we're going to look at graph transformations, which is essentially moving graphs up and down, left and right, squashing them, stretching them, and also reflecting them. Okay, so a combination of those things. So here we have two graphs. We have a cubic graph and we have a trigonometric graph. So we have the sine wave there, which we're all familiar with. Not so familiar with the cubic graph, but this one essentially drops down, hits a minimum turning point, increases again to a maximum turning point, and then starts to drop down again. So let's have a look at, that's just a summary, we'll come back to that later on, guys. So a translation moves every point on a graph a fixed distance in the same direction. The shape of the graph does not change. So essentially we're moving the graph up or down or left or right. F of x plus a moves the graph of f of x up or down, depending if a is positive or negative. If it's positive, it will move up. So here we had the original graph. Let's just scroll back up there. So we have this graph here. If we do g of x plus 1, it will move every point up by 1. So this will go from negative 1, 0 to negative 1, 1. This will go from 3, 0 to 3, 1. Point P won't change because we're not moving in the x direction, so that will move to q plus 1, whatever q is, plus 1. And let's just have a look at that. And there it is indeed. And if a was negative, all the points would move down by 2, so the original graph would move down by 2. So the y coordinates would all decrease. And here's the sine graph. We all know what the sine graph looks like. So there's sine of x plus 1. The whole graph's moved up by 1. There's sine x, y equals sine x minus 1. The whole graph is moved down by 1. And translations parallel to the x-axis. F of x plus a moves the graph of f of x left or right. So here, g of x plus 1 actually moves the graph 1 to the left. So originally, just scroll up again. Originally, the graph was crossing the x-axis at negative 1 and at 3. So g of x plus 1 moves the whole graph 1 to the left. So instead of crossing at negative 1 and 3, it crosses at negative 2 and 2. And the x-coordinate of the maximum turning point was originally p, but we've moved 1 to the left, so it'll be p minus 1. So for example, say the maximum turning point had an x-coordinate of 1.5, it would now be 1.5 minus 1, which would be 0.5. And if the value of a is negative, the graph moves 2 to the right. Okay, and here is an example with sine as well. So y equals sine of x plus 90 moves the sine graph 90 degrees to the left. Y equals sine of x minus 90 moves the sine graph 90 degrees to the right. Let's have a look at a few more examples. So here y equals x squared. So y equals x squared plus 3 should move the whole graph up by 3, which it does. Y equals x squared minus 3 should move the whole graph down by 3, which it does. Y equals x minus 2 in a bracket all squared. Remember, x minus 2 in a bracket should move the graph 2 to the right, which it does. X plus 2 all squared should move the graph 2 to the left, which it does. And let's have a look at another cubic. So we have x cubed minus x minus 1. So that should move this whole graph down by 1. X cubed minus x plus 1 moves the whole graph up by 1. And replacing all x's with x minus 1. So x cubed minus x would become x minus 1 all cubed minus bracket x minus 1. So we don't need to expand that. We just know that that'll move the original graph 1 to the right. Every single point 1 to the right, which it does. And x plus 1 all cubed minus bracket x plus 1 will move the whole graph 1 to the left, which indeed it does. Okay. So to summarize, guys, f of x plus a moves the graph up or down. Notice the plus a is outside of the bracket there. F of bracket x plus a close bracket moves the graph left or right. Left if a is positive, right if a is negative.